All right, so as we work through the second page, the biggest thing on circles is you have to ask yourself, where does the vertex of your angle lie, right? And so a couple things I just might make a note of before we get started here, right? That if it's a central angle, just like we wrote on the front page, right? A central angle is equal to the arc. Okay, and again, a central angle just means that the center is on it. If I have an inscribed angle, right, or if the vertex is on it, okay, then my angle is equal to half of it, right? So if I say on, right, that was the fancy word was inscribed, right? And the inscribed angle is equal to half of my arc. All right, the next thing that could happen is I could have them crisscross. So if we kind of look down at number 26 at the very bottom here, right, I could have an angle whose vertex was inside, right, or on the interior. So we could say it either way. So inside, interior angle, either way, right? But when it was interior, remember that what happened was it opened up to two arcs. And so I took half of arc plus arc, whatever that was. Oh, I'm sorry, you couldn't see that. Okay, so my interior angle was equal to half of arc plus arc. And then the other thing that could happen was I could have an outside angle, right, or exterior. I don't think that's too big of a stretch there. And that was the same thing, except it was arc minus arc. Okay, and again, the big one came first, and then we subtracted out the smaller one, right? So the big arc minus the small arc. Those are the four formulas that you have to know. We're not going to give them to you. OST doesn't give them to you. You have to know what those are. All right, so as we start on our paper, okay, if I look at number 20 here, again, I'm noticing that I've got central angles, which means that the angle equals the arc. Okay, so even though this guy here, it's an angle, I can go ahead and write it on the circumference as well because the angle equals the arc. The other thing I'm going to notice is that I have a diameter, right? So this right here, that's a diameter. And if it's a diameter, that means it cuts my circle in half. So these arcs and the angles should add up to 180 degrees. So 180 should be equal to 2x plus 40 plus an x plus 83 plus a 57. All right, so now if we combine like terms, I've got a 2x, another x. All right, so 180 is going to be equal to a 3x, and then I've got a 40, an 83, and a 57. And so 40 plus 83 plus 57, that should come out to 180. All right, our goal is going to be to solve for x, so I'm going to go ahead and get rid of that 180 on both sides. And you don't panic when you get a 0. 180 minus 180, yep, it's a 0, and that's just fine. Because when we divide by 3, we're going to get that 0 equals x. And that's fine, right? That can happen. X can be a negative number, x can be a decimal, x can be a fraction. We don't panic about that. You solve, you use your math, you're just fine. Question asked for the arc w to x. So we were curious about this one right down here. So if I want the measure of arc wx, that's going to be equal to 0 plus 83, which is just going to get us in 83 degrees. All right, so same kind of thing is going to happen on 21. I'm noticing, right, that all of my angles are central angles. Okay, they all have a vertex on the center of my circle, which means, right, that if I have an angle, I also have an arc. So that 124 degrees is also the measure of that arc. Now, as we look around, right, as I look around my circle, I have measurements for the whole way around. So whereas on 20, I only looked at half, 21, I'm going to look at the whole thing. So 360 is equal to 30. So if I start up here, 8x minus 6 plus 37 plus 17x plus 124. Right, and then the same thing again, we're going to combine like terms. So 360 is going to be equal to, here are my x's, right? So 8 and 17 should give me 25. And then we've got a 30 minus 6 plus 37 and a 124. So 30 minus 6 plus 37 plus 124, I'm getting 185. All right, so go ahead and solve for x. So we'll get rid of that 185 on both sides. So 360 minus 185 is going to get me 175. And then we'll divide. So 7 is going to be equal to x. Now, we're always going to look back, right, and make sure that we're answering the question that was asked. So this was asked, I want the measure, notice I've got angle notation of t to v to s. So this guy right here is what we're concerned about. Now remember, in a central angle, the angle equals the arc. So even though I didn't officially have the angle, I do have the arc. They're going to be the same thing. So the measure of angle, TVS, is going to be equal to 8 multiplied by 7, get rid of a 6. So 8 multiplied by 7, get rid of a 6, should give me 50 degrees. All right, we're going to look at number 22 now. Okay, so I'm noticing, okay, that I've got a vertex, and my vertex is on my circle, right? So if it's on, that's inscribed, which means that my angle is half of my arc. Okay, so of course they didn't ask me for that. They asked me for this piece over here, which is just fine. I know this is 134. To find this arc, right, my angle, 53, is equal to half of the arc that it opens up to, so Q to R, right? So this guy right here. Now, to get Q to R by itself, I would simply double that, right? I'm going to multiply both sides by 2. 53 times 2 is going to give us 106, and that's going to be arc, QR. So this is going to be 106. All right, so ladies and gentlemen, if I know this part of it is 134, this part of it is 106, and I want the other one, notice that my green now goes the whole way around my circle, right? So 360, get rid of 134, get rid of 106, that should leave me with arc, R to P. All right, so let's see what that is. So 360, get rid of 134, get rid of 106, and I've got 120. All right, so the measure of R to P, that minor arc, that should be 120 degrees. All right, so same kind of idea as we look over here at 23. All right, so 23, what I'm noticing is that each one of these vertices is on my circle, right? If my vertices are on the circle, they are inscribed. That's my fancy word, and that means that the angle is equal to half of the arc. All right, so a couple things I'm noticing. First of all, right, I've got angle A, and angle A, if I extend this out just a little so we can see it, I'm noticing that angle A opens up to the arc that we've been given, right? So the measure of angle A, or I guess we could call it CAB, so we're being specific on our name, right? So this guy right here, we'll call it X, that's equal to half of my arc, C to B, right? So that would be half of 74. All right, and half of 74 should be 37. All right, so we know that this guy down here, this is going to be 37 degrees, right? Now, next thing I want to notice, okay, let me find another color here, right? I'm also noticing, right, they were very deliberate. We drew the center of our circle. I also have a diameter here. Okay, if I have a diameter, then I'm noticing that angle B opens up to that. Now, diameters mean, right, that your circle, that this arc over here is 180 degrees, which means, right, that the measure of angle CBA, the pink guy, is equal to half of 180. All right, we talked about this a lot in class, right, that they really like to ask questions, right, where you've got an angle opening up to half of the circle, right, because that gives you a right angle. And so all of a sudden, right, you're allowed to talk about Pythagorean theorem. We can throw trig back in there. We can do special right triangle. So lots of things happen when you get a right angle in here. So you want to be real careful. Now, of course, that neither one of those were the angles that we asked for. We wanted you to find the one up here, but you know that triangles equal 180 degrees, right? So if I get rid of the 90 and I get rid of 37, that should be the piece that's left over, right? So 180, get rid of 90, get rid of 37, and that should leave us with 53 degrees, and that should be the measure of angle BCA. Okay, we're going to look at 24. Now again, I'm noticing all of my vertices are on the circle. So once again, right, I've got inscribed angles, which means my angle is equal to half of my arc. Okay, so I think it might be helpful. We're supposed to be finding A, to B to C. This is the one that we're curious about. I know there's a question mark here, but it very clearly says we're supposed to find the measure of ABC. Okay, so here's what we're going to notice, right? If I go ahead and I open up, because I see an angle here, I open this up, right? Which means that that angle opens up to this entire arc, right? So my angle, let me switch colors, I'll make it pink, right? So the measure of angle, ATC, right, ATC, should be equal to half of arc ABC, right? So this whole thing over here. All right, so 87 is equal to half of, now I'm noticing that ABC is made up of, right, 66 plus that question mark. All right, so let's get rid of that 2. Let's go ahead and multiply both sides by 2. So 87 times 2 is going to be 174 is equal to 66 plus that question mark. All right, and then if we get rid of the 66, 174 minus 66, that should give us 108. And that's going to be equal to our question mark. So right over here, this is going to be 108 degrees. All right, but my question wanted to know, right, so if we look at the other side, my question wanted to know, let me find, sorry, oh, green, you can kind of see green, right? I want this, which means I want this arc. Okay, so what we might notice, right, is that the green and the pink get me all the way around the circle, right? So the measure of arc, ATC, that should be equal to 360, get rid of 108, get rid of 66. So 360 minus 108 minus 66, that's going to get us 186. Right, so this is 186 degrees the whole way. All right, but they wanted the angle, which is fine, right? The measure of angle, ABC, is inscribed, so it's half of the arc that it opens up to. So if we cut 186 in half, we should get 93 degrees. All right, next. We're noticing, right, that I've got an angle and its vertex is on the outside. So if it's outside or exterior, right, either one of those words work, right, then it's half of the big arc minus the little arc. We're supposed to subtract them. So I'm noticing, right, that as we open this guy up, right, we've got 2 arcs. We've got the great big one out here, which I'm going to put that one in blue, and then we've got the inside one in here. All right, so remember we talked about that sometimes when it feels like there is not enough information, okay, that what we would notice is the pink and the blue get me the whole way around the circle. And so your trick was, if we call this X, then the outside one, this larger portion, has to be the whole circle, get rid of whatever that is, right? So if this pink part had been 100, and I'd wanted you to find the other one, you'd have taken 360 minus 100, right? If X had been 15, right, then you would take 360, get rid of 15. So it's the same idea, right? It's just whatever that happens to be, I'm going to take 360 and get rid of it. So my formula becomes that my outside angle, which is 53, is equal to half of the great big angle, or arc, excuse me, the larger arc, so that would be 360 minus X, right? So I'm going to squiggle that. That's the larger arc. And then I'm going to get rid of, that's my formula, the pink part. That's my minor arc. All right, so again, I'm going to get rid of that 1/2. We're going to multiply everything by 2. So 53 times 2 should give us 106, which is equal to 360. Now again, if I combine like terms, right, negative X minus another one should get you a minus 2X. We'll move the 360 to the other side. So 106 minus 360, that should get us a negative 254, which is equal to negative 2X. And then again, to get X by itself, we're going to go ahead and divide by negative 2, which will make our signs positive, so we're doing just fine. That should get us 127 degrees, and that's equal to x, which should be arc EG. Right, so remembering, again, 2 letters, it's a minor arc. If I'd happened to get a number that was larger, then I'd want to be sure I had 3 letters in there, but I didn't. So again, minor arc. If they'd asked you for this outside one, then again, I would take 360 and get rid of the 127, and that would get me the major arc to the outside. All right, so 2 more on this page. So 26, as we look down here, all right, I'm noticing on this one that, again, my angles are going to cross. And so my vertex is on the interior of my circle, inside, which means, right, we talked about that it would be vertical with the other side. And so the arcs that I care about would be the one directly in front of it and directly behind it. Right? So my angle, which in this case would be 70, is equal to half of the arcs that I intersect. So 80 and arc U to N. Okay, so once again, you can choose to either distribute the 1/2 or go ahead and multiply. I would choose to multiply, that way this is gone. So 140 is going to be equal to 80 plus arc U to N. And then if we get rid of that 80, right, 60 degrees, that should be my minor arc U to N. Okay, and then last one. So as we're looking at this one, right, I'm going to notice I've got a vertex on my circle, right? It's going to open up. That's the arc that we care about. So my angle is equal to half of my arc, right? It's inscribed, that's my fancy word, right? But it's on the circle. So my angle, which this time I just have a little bit more algebra, my angle is that 33x minus 1, and that's equal to half of my arc, which is going to be that 65x. Ooh, sorry. Now, you are more than welcome. If you want to cut 65 in half, you can. I probably wouldn't, only because 65, it's not even. So instead, I would multiply both sides by 2. The only trick is because I have a binomial, right? So 2 terms on this side, whereas over here, see, I just had the 1. I just have to remember to distribute, right? So that 2 has to go to each one of those terms. So I would really have 66x minus 2 equal to 65x. All right, so if I get rid of 66x, negative 2 is going to be equal to negative 1x. And then we go ahead and divide by that negative, and so x is going to be equal to 2. Which is great, but again, we always want to make sure that we answer what was asked. I was supposed to find the measure of angle EDC, so I need to plug that in. So the measure of angle EDC is going to be equal to 33 multiplied by 2 minus 1, right? So 66 minus 1, so my answer should be 65 degrees.